So now this video discusses about on how we can be able to sketch the graphs of the trigonometric functions, specifically cosine functions as well as the sine functions. So we understand that we have 6 basic trigonometric functions. We have what we call as the y is equal to sine x, that is a sine function. And we have what we call as the cosine function, which is given as cos x. And we have what we call as the tangent function, which is given as the tan x. And we also have what we call as the cotangent function, which is given as cot x. And we also have what we call as the cosecant function, which is given as the cosec x. We have it as that. And we also have what we call as the secant function, which is given as the sec x. So these are the basic, actually, 6 trigonometric functions. Otherwise, the first 2 actually functions are said to be the fundamental actually functions, and the rest of the functions are formed from the combination of the 2 actually fundamental functions, in the sense that the tan x is the same as the sine x divided by the cos x. And likewise, the cot x is the same as the 1 over tan x. So it is the same as 1 over tan x, which is the same as having it as a cos x. So which is the same as having it as the cos x divided by, which is the same as the cos x divided by the sin x. So which means in all cases, a cot x is the same as cos x divided by the sin x. And the cosec x is the same as 1 over should be sin x. And the sec x is the same as 1 over cos x. So keep that in mind. So our interest in the video is to discuss on how we can be able to come up with the graphs of the sine function as well as the cosine functions. So what you have to understand is that the sine functions possess, so what you have to understand is that the graphs of a cosine function as well as the sine function possess the wave. They possess the shape of the wave. So we call them as wave graphs. So the graphs of a cosine function as well as the a sine function, they possess the shape of a wave. Hence we also call them as actually a wave graphs, because they possess the shape of a wave. So keep that in mind. Now let's say we have a sine function, which is a very basic one. Y is equal to sine x. How do you think we should have to sketch the graph of this function, which is y is equal to sine x? So what did you say? Now, in order to sketch the graph of the sine wave function, first thing you should have to calculate the amplitude. So amplitude is given as the coefficient of the sine x. So what is the coefficient here? The coefficient is given as 1. And the next we should have to calculate the period. So if we say a period, that is the amount to be covered in order to complete one period. So amount can be the angle or the time. So it can be that. So amount to be covered in order to complete one actually, the amount to be covered in order to complete one actually a wave can be a 1 cycle or 1 wave. That's what we call as the period. And how do we calculate the period? And the formula for the period is given as the 2 pi divided by the coefficient of x, and which is symbolized as b. And for this case, what is the coefficient of x? Coefficient of x, which is b, is equal to 1. Therefore, the period is given as 2 pi, because if we substitute 1, it will be the same as the 2 pi. We'll have it as that. And we need to have what we call as the phasor shift. So phasor shift corresponds to where the graph has to start from along x-axis. That's what we call as the phasor shift. In other words, that's the displacement of the graph along x-axis. That's what we call as the phasor shift. How should you have to displace the graph along x-axis? That's what we call as the phasor shift. Or in other words, where the graph should have to start from along x-axis, that corresponds to have it as the phasor shift. So keep that in mind. So how do we have to calculate the phasor shift? So the phasor shift is calculated as we actually equate the inner part of the sine, the inner part of the sine to be equal to 0. For that case, it means we have it as x is equal to 0. And for this case, it means the graph will have to start from x value given as 0. Now, if the x value is given as 0, if we substitute it here, what is the corresponding y value at the starting point? Now, the corresponding y value will also been given as 0 because the sine 0 is the same as 0. Therefore, the corresponding y value at the starting point is given as 0. Therefore, the point is given as 0, 0. So what is the point corresponding to 0, 0? That is the origin. Therefore, the graph of a sine function starts from the origin. So this is how we should have to come up with a graph. And now this is how the graph has to be like. Let me have this properly. And now have it as this. Now for this case, you know the graph starts from 0, that is the origin. So the graph will have to start from 0, that is the origin. And where will the graph have to end? And by the way, the ending point should be the ending point of the graph. So the ending point of the graph should be the ending point. So how do you calculate the ending point? Ending point is given as the period plus the phasor shift. And what is the period? We have it as 2 pi. And what is the phasor shift? We have it as our, hence the ending point is given as a 2 pi. So which means the graph will end at a 2 pi. That corresponds to have it as a 1 period. So the graph will start from 0 up to 2 pi. And now let's think of dividing the region into 4 actual parts. Now how should you have to divide the space into 4 parts? So first thing, we should have the midpoint of the 2. So the mid of the 2, that is 0 as well as the 2 pi, is given as pi. So this is the midpoint. And what is the midpoint between the 2? So the midpoint between the 2 is given as 2 pi plus pi divided by 2, that is the same as 3 pi divided by 2. So which means the midpoint is given as should be 3 pi divided by 2. That is the midpoint. Should be divided by 2. We'll have it as that. That's the midpoint. So it should be a 3 pi. Let me have this one properly. To have it as a 3 pi divided by 2. That is the midpoint. And what is the midpoint of the other part? So the midpoint here is given as a pi over 2. We'll have it as that. So how should you have the graph? So now the first thing is that the amplitude is given as 1. So the graph will go up to 1. And that the graph also has to go down with the same amplitude. But now since this side is of the negative values, we'll have it as a negative 1. So it should be that. And how should we have the graph? So the sine wave function will go like this. So it should be the sine wave graph will go like this. So the graph will start from the origin, then it will go up here. So we'll go like that. We'll have to go like that. Then we'll go down here, it should be that. And then from there we should have to go here. So then the graph will go like this. And by the way, it should be a typical curve. Then the graph will go like that. And from there, then the graph will go like that. So that is the graph you should have to understand. And this is how you should have to understand about the graph of that case. So that's how you should have to understand it. So the amplitude corresponds to the distance from the origin position to either up and down. And at this point is said to be the maximum point, and this is said to be the minimum point. So what are the coordinates here? So the coordinates associated, actually the coordinates associated with the maximum position here are given as, what is the x value? We have it as, should be pi over 2. And what is the y value? We have it as the positive one. So we have it as a positive one. And what are the coordinates here? So we have that one as, this is 3 pi over 2 comma negative 1. So those are the coordinates there. And what are the y-intercepts? So should be the x-intercepts. X-intercepts, so those are the points in which the graph is actually attaching, in which the graph is passing through the x-axis. So the x-intercept is given as the pi as well as the 2 pi. So keep that in mind. And now what if, let's say we have this case, let's say we have a function y is equal sine, let's say 2x. So how do you think we should have to sketch the graph of this function? Now first thing, we should have to determine the amplitude. What is the amplitude? Now the amplitude is given as, it should be 1. And we need to have the period. What is the formula for period? Is 2 pi over the coefficient of x. So what is the coefficient of x? We have it as 2. And therefore the period is given as a 2 pi divided by 2, which is the same as pi. And what is the phasor shift? So the phasor shift is calculated upon equating the inner part of the sine being equal to 0. So have it as 2x is equal to 0, and therefore x is given as 0. So it means the graph has to start from the x value 0, and what is the y value corresponding to x value 0? If we substitute it here, it means the y value is also equal to 0. Therefore, the graph starts from the origin, which is 0, 0. So that's where the graph will have to start from. Now for that case, where would the graph ending at? So the ending point. So the ending point should be, the end point has to be given as the period and plus the phasor shift, which is given as 0. So have it as a pi. So how should you have the graph for that case? Now this is how we can have it. And now we have the amplitude, which is given as 1, and also that is 1. And the graph starts from 0 to actually pi. And let's think of dividing the region into 4 actually equal segments. So which means the half of the 2 is given as pi over 2. Now what is this and what is this? So how should you have that? So let's have that one first. So have it as 2 should be pi over 2, should be pi over 2 plus pi, and overall divided by 2. And using the butterfly method, we should have to add those fractions. That will be given as a pi times 1, that is a pi, and the 2 times pi, that is a 2 pi. We'll have it as a 3 pi divided by 2. So it should be that. It should be that. Or else let's use the ordinary way of adding fractions. So we have a pi over 2 plus a pi over 1 in the overall divided by half, rather divided by 2 should be that. And what is the common denominator? We have it as 2, like that. In the 1 into 2, that is a 2. 2 times pi, that is a 2 pi. And 2 into 2, that is 1. And 1 times pi, that is a pi. If you add those, we'll have it as a 3 pi over 2. Really, it works in that way. So make sure you understand about the butterfly method as a technique of adding fractions. And also it is used whenever we are subtracting the fractions. And basically this is now 3 pi over 2. And how about t? So for that point to have it as a pi over 4. So that corresponds to have it as 0 plus this divided by 2. We'll have it as that. Then now the graph has to go like this. So which means the graph will go up here at that point, then the graph will go down like that, and the graph will have to go like that, and the graph will have to go like that. So that's how the graph has to be. And how about, let's say, and from there you can be able to have the coordinates at the maximum position as well as the minimum position here, and also the x-intercepts as well, as you can see there. And what if, let's say, we have this kind of a graph, should be a function. Let's say we have y is equal to negative, let's say, sine x. So how do you think we should have the graph of that function? So now, since we have a negative coefficient, it means the graph will be refracted. And now for that case, what is the amplitude? Amplitude is almost positive 1. And that is, in the period was Stromo being given as 2 pi, according to the principles behind. And the phase achieved is Stromo being given as should be 0. And the ending point is Stromo will be given as Stromo will be given as 2 pi. So even if you can try to follow up the steps, you also have it the same way. And how should you have the graph? You know, the graph will go in the same way, but now it will be refracted, and that is a refraction along x-axis. The graph will have to reflect along x-axis. So it should be that the graph starts from 0, and it is ending at 2 pi. And now the amplitude is given as 1, should be that, should be negative 1 here. And now we should have to divide the region into 4 equal parts. So have it as this is a pi, and this is 3 pi over 2, and this is a pi over 2, should be that. And now since we have a negative here, it means the graph has to be reflected, in the sense that instead of going like this, then the graph will have to go like this. So that is, the graph will go like that, and the graph will go like that, and the graph will go like that. So that's how you start understanding. And from there you can be able to determine the coordinates at the maximum position as well as the minimum position, and also the coordinates in that way. So it should be that. And let's say we have this kind of a case. Let's say we have it as, let's say, y is equal. So now what if, let's say, we have this case? Let's say we have negative 2, let's say sine 2x minus, let's say, 5. So how do you think we should have to sketch the graph of this function if that is the case? You know, principle remains the same. What is the amplitude? The amplitude is given as the positive 2. That is the coefficient of, should be a sine. So the amplitude is given as the positive 2. And now, what is the coefficient of x? We have it as a positive 2, which is this. And now from there we can be able to have the period. What is the period? The formula is given as the 2 pi over b. Now which is given as, now the period will be given as a pi. Because if we substitute 2 here, we'll have it as 2 and this 2 will cancel. We'll have it as pi. And from there we should have to calculate the phasor shift. So what is the phasor shift? Now the phasor shift should be the phasor shift. How should we have the phasor shift? We should have to equate the inner part of the sine equal to 0. So for this case, we'll have it as 2x minus 5, and we should have to solve for x. Now x is given as 5 over 2. That is what we equate as the phasor shift. So like that. Now for this case, what it tells is that what is the ending point of the graph? What is the end point of the graph? We'll have the period from the actually a period plus the phasor shift, which is a pi plus 5 over 2. And what it tells is that we'll have it as, 2 pi, 2 times 2 pi, that is 2 pi, and plus 5 over 2. That is what we equate as the ending point. So that's why the graph will have to end. So that is how the graph will be actually ended. So now we have that understand. So here are the parameters that we have. So we have the amplitude given as 2, and we have the period which is given as the pi. We have the phasor shift which is given as should be 5 over 2, and we have the ending point should be the end point of the graph, and which is given as the 2 pi plus 5, and basically divided by 2. We'll have it as that. So now we can be able to graph the, actually to sketch the graph. And now the graph will have to go like this. And I will have it as that. We'll also have it as this. And now what is the amplitude? We have it as 2. And also this is negative. We'll have it as a negative 2. And the graph is ending at should be 2 pi and plus 5 divided by 2. Like that. And we should have to, and the graph is starting from 5 over 2. So the graph is starting from 5 over 2. It is no longer starting from 0 because the phasor shift is given as 5 over 2. So it should be that. So let me just have to at least we should have to make it long. So let's think of having that. Then I should have to divide the lesion into 4 equal segments. And what is the half of this? So what did you say? The half is given as, we are here, and we should be here, and also we should be here. And what is the half there? So the half is given as should be 5 over 2 plus 2 pi plus 5 divided by 2 and times 1 over 2. We'll have it as that. If we think of adding those fractions, what we'll have is, we'll have it as 10 plus 2 should be 10 plus 2 pi divided by 2. If you factor out actually a 2, what we'll have is, we'll have it as 5 plus pi and times 2 should be times half, which corresponds to have it as 5 plus pi over 2. So that is the half of that one. So 5 plus pi divided by 2, that is. And at that point, then at your own time, you should have to try to you should have to calculate what is this and what is this at your own time. But now, how should you have to sketch the graph? And since it is negative, it means the graph will have to be refracted. So the graph will go like this, and will have to go like that, and the graph will go like that. So that's how the graph has to be. So make sure you are accurate in your sketchings. No, actually it should be this, not from the way it is. It should be this. The graph will have to go like this. And the graph has to go like this. And it has to go. And by the way, my sketchings are very poor. Me just have to label this. Then I should just have to label this like that. So which means the graph will have to go like that, and I should have to label it T. So I should have to label it T. By the way, it should be there, not T, but it should be here. So it means the graph has to go like this, and like that, up to this point. So that's how the graph has to be of that case. And let's say if we have this case. So let's say if we can have, let's say, a function given us, let's say it should be a y is equal to, let's say, negative 6 sine of, it should be a 5x pi, and let's say minus 1 over 2. So how do you think we should have to sketch the graph of this function if that is the case? You know, principle remains the same. We have the amplitude, which is given as 6. So the amplitude will be given as 6. So have it as that. And we should have to calculate what is the coefficient of x. Now for this case, by the way, I should have this one as this. Now we should have it as 5 pi x. Now the coefficient of x is given as 5 pi. And what is the period? We'll have it as 2 pi divided by 5 pi. Like that. And now in this case, what will happen is that we'll have it as a pi and pi will cancel, and then the period is given as should be 2 over 5. That is the period. And now we have the amplitude given as 6, and the period is given as 2 over 5. Like that. And how should you go actually much about? We need to have the phasor shift. So the phasor shift is calculated upon solving for x. So where we have to equate the inner actually part of the sine equal to 0. So have it as 5 pi x minus half is equal to 0, which to have to eliminate the denominator, we'll have to multiply everything by 2, and that will be given as should be 0. And what it tells us that we'll have it as 10 pi x is equal to 1. Then the x is given as 1 over should be 10 pi, like that. So that is what we call as the phasor shift. So phasor shift is given as 1 over 10 pi, like that. And where would the graph be ending at? So the ending point of the graph. So the ending point of the graph is calculated upon having the summation of the period as well as the phasor shift. So how should you have that one? Now have it as 2 over 5 plus 1 over 10 pi. And that corresponds to have it as what is the common factor, what is the common denominator? I'll have it as 10 pi. Then at 10 pi into 10 pi, I'll have it as 1. And 1 times 1 given as 1. And 5 into 10 pi, I'll have it as 2. And the 2 times 2, that is should be 4 pi. So that is actually the ending point. That's where the graph will be ending at. So that is the ending point. The end is given as 4 pi plus 1 divided by 10 pi. So have it as that. And now from there, we should have to look at how the graph will look like. So that is a sine function graph. Should be that is a sine function. Then have it as that. And the amplitude is given as 6. So which means we'll have it as, it should be 6 here, and to have it as a negative 6 here. We'll have it as that. And the graph starts from 1 over 10 pi. Let's say this is a point. That is 1 over 10 pi. That's where the graph is starting from. That is 1 over 10 pi. And the graph is ending at, should be 4 pi plus 1 divided by 10 pi. Like that. Then we should have to divide the lesion into 4 equal parts. To have this, and actually this point, as well as this point. So let's first of all have that one. So have the average of the two values. So that corresponds to have it as 1 over, should be 10 pi and plus 4 pi plus 1 divided by 10 pi. We'll have it as that, in the times half. It should be that. And if we think of combining the two fractions, what we'll have is, I'll have it as 2 plus 2, okay, 2 plus 4 pi, and I divide by 10 pi, and the times it should be half, and which corresponds to have it as 2 plus 4 pi, and I divide by 20 pi. And let's think of actually factoring out the 2 there. I'll have it as, will be given as 1 plus 2 pi, and I divide by 10 pi. So that's the middle of the two values. We'll have it as 1 plus 2 pi divided by 10 pi. So that is. So at your own time, you should try to complete the, actually, you should have to complete, let's say you should have this as well as that, using the same principle. Now since it is negative, it means the graph is refracting. So this is how the graph has to go. So we'll have to go at this point, it also go at this point. This is how it has to go. So have it as that, the graph will go like that, and the graph will go like this. So this is how the graph has to be. And basically this is the maximum point and this is the minimum point, that you can be able to have their respective coordinates. So like that. So how about, let's say if we have a case like this. So let's say if we have a case like this. Let's say we have a function y is equal to, me use something like here. Should be, let's say y is equal to negative 2. Let's say sine of, let's say, a pi x, and let's say plus x. It should be plus pi. So how do you think we should have to go over this? You know, principle remains the same. What is the amplitude? We have it as 2. That is the amplitude. So the amplitude is given as 2. And now we need to have, what is the value of b, which is the x, actually is actually a coefficient of x. We have it as pi. And the period is given as 2 pi divided by pi, which is given as 2. So which means the period is which means the period is given as 2. So have the period being given as 2, like that. And the next we should have to calculate the phasor shift. So how should you have the phasor shift? We'll have to solve for x upon equating the inner part of the sine equal to 0. Now what will happen is that we have it as a pi x plus pi, which is equal to 0. And what it tells is that we have it as a pi x is equal to negative pi. We'll have to divide everything by pi. That will be given as x is given as the negative 1. So that is the phasor shift. That is equal to, should be a negative 1. That is a phasor shift. So by the way, a phasor shift corresponds to the x value. So some books you see that one being given as the phasor shift is given as x is equal to negative 1. You know, it means the same. That is a phasor shift. Then where will the graph be ending at? So the ending point corresponds to have the summation of the phasor shift as well as the period. So where will the graph ending at? The ending point. So the ending point is given as the x is equal. So what is 2 plus negative 1? That is a positive 1. So the graph will end at the x negative 1. And now, how should you have the graph of that case? So the graph will go like this. So this is how the graph has to go, right? And now the graph will start from, what is the phasor shift? We have it as a negative 1. It means the graph is starting somewhere here. That is, let's say this is negative 1. And the graph is ending at a positive 1. Now for that case, let's say this is a positive 1. So we have the amplitude, which is given as it should be 2. So have it as 2 here, and this is a negative 2. Have it as that. And now we should have to divide the region into 4 actually parts. But let's just have to come up with the midpoint of the 2. That is the origin. So this is the midpoint, and that is given as 0. And to have that and as that, we'll have that and as that. So now since this is the negative, it means the graph is refracting. So the graph, you know, the graph has to go, that means the graph has to go like this. And by the way, it means the graph has to go like this. And that the graph has to go like this. And the graph has to go like this. Of course, that is a graph you should have. And what if, let's say, we have this kind of a case as well? And now let's say we have it as, should be y is equal, let's have this, let's say we have it as y is equal, let's say 2 minus, let's say, should be plus, let's say sine x minus, should be plus, let's say pi over 2. So how do you think we should have to sketch the graph of this function? You know, the only difference with this one is that we have another, actually a parameter we should have to consider. So this parameter is said to be the vertical shift, and it tells on how the graph has to be shifted along y-axis. This is said to be the vertical shift. And since it is positive, it means the graph has to be shifted about 2 steps up. That's what we get as the vertical shift. That's the difference with the other actual functions that we have looked upon. But now this is what we get as the vertical shift. But everything in principle remains the same. What is the amplitude? We have it as a positive 1. And what is the value of b? We have it as, it should be 1. That's the coefficient of x. And what is the period? We have it as 2 pi over 1, which is given as the 2 pi. So which means that's the period. So period is given as 2 pi. We have it as there. and I need to have the phasor shift. What is the phasor shift? We should have to equate this equal to 0 and so for x. So what it entails, what it entails is that we have it as x, and plus pi over 2 is equal to 0. And now for this case, we have it as x is equal to negative pi over 2. That is a phasor shift. That corresponds to have it as x is equal to negative pi over 2. That is a phasor shift. And by the way, again, the phasor shift corresponds to the x value. So that is x is equal to negative pi over 2. And now we should have the ending point. Where would the graph has to end at? So the ending point is given as the summation of the phasor shift as well as the period. And that corresponds to have it as 2 pi and minus pi over 2. And what is that? So let's think of having the fractions. We have what is the common denominator. We have it as 2. That is a negative pi. We'll have it as, it should be a positive of 4 pi. That is, now we have it as a 3 pi over 2. That is the ending point. So which means the graph will end at should be 3 pi over 2. So ending at x is equal to 3 pi over 2. So keep that in mind. And now how should you have the graph? So it should be that. But now since we have a vertical shift, it means the graph will be drawn from along the horizontal line drawn at y is equal to 2. And what is the vertical shift? Well, we have it as should be 2 here. This is the vertical shift given as 2. So which means the graph will be drawn along this line, since that one is the vertical shift. Now if the amplitude is given as 1, how far should we have to travel from 2 up to that direction with the amplitude given as 1? So you observe that the amplitude for this case, and since the amplitude is 1, is actually, it means from 2 will be at 3 here. So this is 3. And from 2, since the amplitude is 1, a down will be at the actually 1 here. So that's how it will be. So from 2 either actual directions, the amplitude storm is given as 1. So that's how it will be. Now how should you have to plot the graph? So the graph is starting from the phasor shift actually x and negative pi over 2. So which means the graph is starting from, should be at the back here. So the graph is starting from the back, and it should be that. And the graph is starting from negative, should be a pi over 2. This should be the point. Let's say this is negative pi over 2. And the graph is ending at 3 pi over 2. And this is where the graph is ending. 3 pi over 2. That's how you should have it. So what is the midpoint of the 2? Let's say this is the midpoint. I'll have it as that. And we should have to divide into, should be 4 segments. So let's say that is given as that. We'll have it as, this is that one as that. So let's say this is the midpoint. And how should you have it? So negative pi over 2 and plus 3 pi over 2 in times half. That is given as, we have it as 2 pi over 2 and then times half. That one I start to have it as a pi over 2 as the midpoint. So this is a pi over 2. Since it is positive, it means the point is in this actually a quadrant that is a positive. So which means the graph will have to go about. So since this is a positive, it means the graph will start from here up and down. It should be that. So this is how the graph has to go. So the graph will go up to this point. It means the graph will go up to this point, and the graph will go down up to this point, like that. So this is how it has to go. We'll have it as that, and we'll have it as this, and the graph will go like this, and the graph will go like this. So that's how you should have it. And let's say if we have this kind of a case, how do you think we should have that on? Let's say if we have it as, let's say y is equal to -3, let's say -2, and let's say 5x, and that should be -10. So how do you think we can have to sketch the graph of this function if this is the case? So we still have the vertical shift that is in -3. It means the graph has to be shifted about 3 steps down from the origin. So what is the amplitude? Amplitude is given as 2. And what is the coefficient of x? We have it as a +5. So which means the phasor shift is given as 2 pi over 5. In that way. Then what is the phasor shift? The phasor shift is calculated upon solving for x. So in the sense that we should have to equate the whole of this one equal to 0. That will be given as 5x minus 10 is equal to 0. And the x will be given as, should be about 2. So a value of x is given as 2. That is a phasor shift. So phasor shift is given as x is equal to 2. That's where the graph is starting from. Like that. And what is the ending point? So the end point is obtained upon having the period from the actually a period and plus the phasor shift. That is a 2 pi over 5 plus 2, and that is a 5. We have it as 10, 2 pi. So now the ending point is given as x is equal to 2 pi plus, it should be 10 divided by 5. That's the ending point. So like that. So how should you have the graph of that function? So now to have is we'll have it as and now we are having the vertical shift, which is given as the -3. It means the graph has to go about 3 steps down. Let's say if that is the case, we just have to it means the graph has to be shifted about 3 steps down. Let's say this is -3. It means the graph will be drawn within this center line. We'll have it as that. So if the amplitude is given as 2, how far should we have to move from -3 up here? It means we are to be at -1. That should be that. And here we should have to be at it should be 5. Because Stromal amplitude is given as -2. It should be actually, it should be Stromal amplitude will be given as the 2 if you add through onto that. So the amplitude Stromal is given as a +2. And now the graph starts from should be 2 pi over 5. Let's say this is the point. So 2 pi over 5, and the graph is ending at the point should be 2 pi plus 10. So 2 pi plus 10, let me have this proper. And the graph is ending at 2 pi plus 10. let me have this. That's 2 pi plus 10 divided by 5. Then I should have to divide the space into 4 equal parts. Let's say this is the middle part, or have it as that, or have here as well as the here. Let me use something here for you to clearly see what's going on there. So we have that and as that. Then the graph has to be, then the space has to be divided into 4 equal parts. That is that, that is that, and that is that. So since this is the negative, it means the graph has to be reflected. So at your own time, try to have what is the middle part, what is the middle part, and what is the middle part in terms of the actually the values. But now the graph has to go like this. The graph has to go like this, and the graph has to go like this. So which means the graph will go like this, the graph will go like that, and the graph will go like that, and the graph will go like that, and the graph will go like that. So that's how the graph has to be. I understand now you know what is all about the graphs of the sine functions. You're looking at the amplitude, the phase shift, the ending point, as well as the vertical shift. Let's now extend our discussions by looking at the sine, cosine graphs. Now the basic graph of the cosine is given as, you know, principle remains the same. What is the amplitude? We have it as 1. And what is the period? 2 pi divided by, what is the coefficient of x? We have it as 1. Therefore the period is given as 1. And what is the phase shift? We have it as x is equal to 0. So therefore the phase shift is given as the x is equal to 0. That is the phase shift. And what is the ending point? Ending point is given as the period, actually a period plus the phase shift, which is given as, should be given as 2 pi. That is the period. X is equal to 2 pi. But now, if the phase shift x is equal to 0, what is the y value corresponding to x is 0? So the y value corresponding to x is 0 is given as, it should be if the phase shift is given as x is 0, what is the y value corresponding to x is 0? So the y value is given as 1 because the cos 0 is given as 1. Therefore, the graph of this actually a cosine function, you know, starts from 0, 1. We'll have it as that. So this is how the graph has to be plotted. So this is how the graph has to be plotted. You know, amplitude is given as 1. That is okay. We have it as 1. It should be that -1. And now the graph starts from 0 to, it should be 2 pi. We should have to divide the region into 4 equal parts. And for instance, this is the middle part, which is pi. And what is this? 3 pi over 2. And this is pi over 2. You know, principle remains the same. But now, on the sine, actually on the cosine functions, the graph will start from 0, 1 and goes down. So which means the graph will start from here. That is the point corresponding to x is 0 and y is given as 1. Now actually the graph will go like this. Then the graph will go like that. And from there the graph will be that point. And the graph will go like that. And the graph will go like that. So this is how we should have it. As you can see, this is the quarter making it half. And plus this half, we have the full wave. So that is okay. So that's how you start to understand about the cosine, you know, the graphs. Let's say if we have it as, let's say y is equal, let me have this. Let's say have y is equal, should be, let's say, negative cos let's say negative cos 2x minus, let's say, should be 4. So how do you think we should have to sketch the graph of this function? Principle remains the same. Now, what is the amplitude? Amplitude is given as 1. And what is the coefficient of x? We have it as 2. Therefore, the period is given as 2 pi over 2, which is the same as the pi. So therefore, the period is given as, should be pi. That is the period. We have it as a period being given as pi. And now, what is phase shift? We'll have to equate this equal to 0, and so for x. So for that case, we have it as 2x minus 4 is equal to 0, and therefore x is given as 2. Like that. And therefore, that is the phase shift. So that is a phase shift. That is x is equal to 2. And how about the ending point? Where will the graph end? So the end is calculated as the phase shift plus the period, which is given as 2 plus pi. That's where the graph will end at. And now, since this is negative, it means the graph will have to reflect. So how do we reflect the cosine functions graphs? How should you have to reflect that one? How should you have to reflect the graph of a cosine function? The graph will start from x being equal to 2. Have it as, this is where the graph is starting from. That is the phase shift. And the graph is ending at 2 plus pi. That's where the graph is ending at. So we should have to divide the lesion into 4 equal parts. And that will have it as, what is the mean of the 2? We'll have it as 2 plus pi divided by 2. And that will be given as, should be 4 plus pi over 2. So that is the mean. So 4 plus pi over 2. And now at your own time, try to complete the other 2 points. Like that. Then how should you have that one? We have the amplitude, which is given as 1. That is okay. That is amplitude 1. And that is amplitude negative 1. But now, since we have the negative, it means the graph is reflecting along x. So instead of starting like this, then the graph will start like this. That's what will happen. So how should I have it? Now the graph will start from here, and will go down like that. And the graph will go like that. By the way, let me just have to do this. So the graph will start from here, and will be at that point. Then the graph will be at this point. That's what will happen. So which means the graph will go like this. Then it will go like that. The graph will go like this. And by the way, it should be here. Then the graph will go like this. So this is how the graph has to be, as you can see. So it should be that. So what if, let's say, we have this kind of a case? What did you say? Let's say if we have it as should be y is equal, let's say we have y is equal to 2 and the minus, let's say 3 cosine of, let's say, negative pi x and about, let's say, 2 pi. So how do you think we should have to sketch the graph of this function? Principle remains the same. We have the amplitude, which is given as 3. And of course, we also have the variable shift, which is okay. And what is the coefficient of x? That is b. We have it as a negative pi. And therefore, the period is given as 2 pi over negative pi. We'll have it as negative 2. That is the period. So which means the period is given as negative 2. That is that. And I would have to calculate the phase shift. That is a negative pi x plus 2 pi is equal to 0. Therefore, have it as negative pi x is equal to negative 2 pi. And that corresponds to have it as x is equal, now the x will be given as the positive 2. That is, so that is the phasor shift. That is x is equal to positive 2. And what is the actually ending point? So the ending point corresponds to half the period and plus the phasor shift, and which is given as L. So which means the graph will start from negative 2 and the graph will end at 0. That is the ending point. And how should you have that one? You know, principle remains the same. And now since the phasor shift is negative, it means the graph is starting from back. So like that. And the phasor shift is given as a positive 2. It means the graph has to be shifted about 2 steps up. So this is where the positive 2 has to be. And I'll have to draw the horizontal line in that way. And if the amplitude is 3, how far should we have to move up from 2 to satisfy that one? So which means we'll have here as 5. And how about down? We'll have here should be given as negative 3. Because if from 0 to the origin, that is 2, should be from 0 to origin, that is 2, and from origin to negative 3, that is 3, that is given as, and by the way, should be given as, should be from 0, actually from 2 to origin, that is 2, and which means we should have here as a negative 1. So that is negative 1, should be that. So we should have that one as a negative 1. And at least it should be here. We'll have it as a negative 1. And such that we should have the amplitude as being given as actually 3, as it is here. And now since this is the negative, it means the graph will reflect. So the graph will start from, you know, a negative 2. That is negative 2. And the graph is ending at x is 0. So this is where the graph is ending at. So we should have to divide the region into 4 equal parts. And that is the middle. We have this is the middle of that one. So that is negative half plus 0. Should be negative 2 plus 0, that is negative half. Then we have this as this. And you can evaluate those values on your own. But now how should you have the graph? Now since this is the negative, it means the graph will start from down. And this is where it will start from. So the graph will start from here, and in line with the amplitude, this is where the graph will start from. And it will go down like that. Then the graph will be there. We'll have it as that. And the graph will go like this. And from there the graph can go like that. So that is the graph of that case. So that's how you start to understand about such kind of a graph in that way. So what if, let's say we have this, let's say we have a function y is equal, and it should be 1 minus, let's say cos of 2x, and that should be minus, let's say pi over 3. So how do you think we should have to sketch the graph of this function? You know, principle remains the same. What is the amplitude? We have it as a positive 1. And what will be the period? Period is given as a 2 pi over, now what is the coefficient of x? That is 2. Therefore the period is given as pi. And now we should have the phasor shift. That is 2x minus pi over 3 is equal to 0. And now for this case we'll have it as 2x is equal to pi over 3. It should be that. And now the value of x is given as, we should have to we should have to divide both sides by a 2, or else let's think of multiplying everything by 3. It is the same. So have it as a 6x is equal to pi, of which x is given as the pi over 6. So have it as that. So that is what we call as the phase shift. So phase shift is given as x is equal to pi over 6. That is a phase shift. Then from there we should have where will the graph be ending at. So what did you say? So the ending point. So the ending point corresponds to pi, that is the period, plus the phase shift. That is pi plus pi over 6. And that is what is the common denominator, that is 6. And that is pi plus 6 pi. That is equal to 7 pi over 6. So that's why the graph will have to end at 7 pi. That should be 7 pi over 6. That is the ending point. Like that. And now let's think of having the sketch of the graph. So we have the vertical shift, as you can see, that is positive 1. It means the graph has to be shifted about a single step up. So have it as that. So this is where a positive 1 has to be as a vertical shift. So this is the line in which the graph has to be drawn in, like that. And the graph starts from what is the phase shift, that is a positive pi. So the graph will start from, let's say this is a positive pi, and the graph will end at, let's say this is a 7 pi over 6. So in your case, as you be sketching, make sure that you need to use you should be pencils as well as the rulers whenever you are giving the scales. So it should be that. Then I should have to divide the region into 4 equal parts. And this is the middle of it. And what is the middle of the 2? Thus we'll have it as a pi plus a 7 pi over 6. It should be, what is that in times 2, by the way? Times half. So that is, we can have it as 6. And a 7 pi in the plus, we have it as 6 pi. And that is now 13 pi divided by, what is 2 times 6? That is 12. So which means we have it as 13 pi divided by 12. We'll have it as that. And from there, this is the middle, also this is the mid. You can have to evaluate those values. And how should you have it from there? So this is how you should have it. For now, you can have to draw the graph of the function. So what is the amplitude? So from 1, how should you have the amplitude given as 1? Will be at 2. And how should you have the amplitude as 1 from 1? So this is I'll have it as L here. So in all cases, from 1 to 2, amplitude is 1. From 1 to 0, that is amplitude given as 1. So that is. And now since this is the negative, it means the graph is refracting. So the graph has to start from, start from here and down. It should be somewhere here. It should be that. So the graph will go like this. And the graph will go like that. And then the graph has to go like this. From there, the graph has to go like this. So that's how you should have it. So that's how you should have to understand about how the graph will have to be sketched. So that's how we do it. So try to sketch the following at your own time. And I should have to sketch the following graphs. We have, let's say we have it as y is equal to sine 3x, let's say plus 5. Let's say that is the case. And by the way, this is a vertical shift. What if, let's say, we have sine 3x plus 5? So this one are different. And what if we have, let's say, y is equal, let's say 4 cos x should be 4 cos 2x divided by pi and the minus 4. How should you have that one? Let's say have y is equal, let's say have sine, it should be a pi x over 2 minus 4. How should you have that one? Let's say y is equal, should be 3 sine, let's say half x and plus pi over 6. Let's say that is the case, and let's say half y is equal, let's say half sine, let's say pi over 7 minus, let's say pi, should be x pi. So how should you have that one? So try to have that at your own time. And what if, let's say, we have this as well? And also finally try to sketch the following graphs. Let's say -2, -10, sine x plus, let's say 5. Let's say half negative, let's say half, plus 2, let's say cosine of 2 pi x minus, let's say half. Let's say y is equal to negative, let's say 5, -4, let's say sine of should be x minus 2. So try that. Now here's the question for you. How do you think we can have to sketch the graph of the cosine as well as the sine if we are if we are being given the specific interval? Let's say we should have to draw the graph of y is equal to sine x in the interval from, let's say, -6 pi, and that has to be to, let's say, 3 pi. So how do you think you can have this? So try to search out how you can have that. Otherwise, based on your responses, that will actually prompt me to come up with a video about how we can have to sketch the graph of the cosine as well as the sine, specifically if we've been given the interval in which the graph has to be. So, but the basis of all those things, the basis of that case, the basis of having the graphs of the trigonometric functions, the sine as well as the cosine, is what we have done it here. Thank you.